It would be 2003 is when I first came.
2003. I joined in 09.
Probably late 2003, maybe early. Xander was my. If you.
Mm-hmm. I know our building is right next to USAA, and I think their shop is mostly Java based. I'm not sure what everyone else is running. Boeing's there. I'm not sure what Intuit's running though. Sorry, guys.
We only do it because we know it just makes you stronger.
But I'm super happy, Russell. I'm happy. I'm happy it's your birthday. And I'm happy.
Happy birthday!
Birthday.
Hey, that was me.
I prefer the key of F minor.
I prefer
sus4.
F sharp in this house only, David.
It is real close. I was just about to check the signups. We had 36 signups earlier, and let me see what we have now. I don't know if I sign into the right thing.
43, beach to it.
43. All right. Yes.
Eric said that Norm would be steaming today.
Yeah, I didn't know how much you guys wanted to advertise, because it's sort of the weird thing with user groups. Like, do you really want people all over the country, or do you guys want to keep it local? So that's why I didn't myself tweet much about it. I just,
I mean, this day and age, I mean, we've done a couple of meetings with folks from different places, and now with us doing it on Zoom instead of in a physical location, it's definitely, we feel a little more free to invite folks elsewhere. Because before, I mean, a lot of times it's hey, are you coming to Dallas soon, or or something like that, and not, some people are, they travel speakers and so on and so forth. But I mean, with this, I mean, I've gotten to really enjoy this. I do miss the face-to-face though with people in the meeting room, and I'm sure that a substantial percentage of our attendees do miss the free pizza and soft drinks we bring once a month also. Thanks to our sponsors. Well, hey, when you come down to Dallas, we'll have you here, and we'll have you speak again, and we'll get some pizza. Just tell us what kind you like. As long as it comes from Domino's or Papa John's, because that's who I have the agreements with.
well, I live in a house of vegetarians, so I just try to get a meat pizza whenever I can. So.
Yeah, there's a few folks that are like that. Yeah. Why didn't that one?
So is everyone ready for? Excuse me. Is everyone ready for .NET 5? Switch over to that.
I'm just trying to get everything upgraded to PHP 7 right now.
Ooh. There it is.
Why?
I haven't quite made it to .NET yet.
I only care about .NET frameworks that run in AWS Lambda.
Well,
that's all I'm in. That's all I'm in anymore. So that I don't care. As long as my pipeline doesn't break, I'm good.
All of our stuff I mean, we could run it on, whenever .NET 5 is like really out, because we're just pushing it all in Docker, except for our Lambdas and our Kinesis events. And so, yeah, that would be pretty cool. But if we do have all of our builds in Docker, we don't have to worry about our build infrastructure, and then just extract it, and there you go. And that might be something that Norm's going to talk about, so maybe I'll stop talking. No.
Admittedly,
yeah.
I didn't know like the AWS knowledge here level, so it was sort of playing like. So mostly, I was just planning on talking more like the application construction and how do you actually use some of the libraries and codes and things like that. My hope, this is a small group. Like I have a set of demos that I'm happy to go through. If we derail the conversations to other places other people want to go, I'm good with that too. That's sort of I have a rough PowerPoint slide to go through, but yeah, feel free to derail and go wherever.
So I guess at this point, I'll go ahead and, since we're already talking about it, I'll go ahead and introduce you. So tonight, welcome to the October edition of the .NET Developers Group. We are very happy to introduce Norm Johansson. He's on the AWS team, and he was very prolific, and he's probably the only person that did all the .NET things at reInvent last year. There are a few other people, that's true, but I saw Norm a lot last year, and I saw a couple of months ago that he had done a talk somewhere, and the lights went off, in my head, the really dim ones. And I was like, hey, I'm going to ask Norm to see if he'll come and speak for us. And we're able to work it out. So I'm very happy to have Norm here. And I can't wait to hear what he has to talk about. And hopefully we can have some good, lively discussion with him. So Norm.
All right. Cool. Yeah, thanks so much for having me. I will share my screen. I am going to admit that I'm not a Zoom expert, so bear with me.
There you go.
All right. Everyone see the brilliant PowerPoint skills that I got? So yeah, as David mentioned, I am a longtime dev over AWS. I spent all my time focusing on all the .NET tooling over there. I've been doing that for about 10 years now. So what I wanted to talk about today was really like what it takes, to actually build an AWS .NET core application on AWS. And, I know we've got .NET 5 coming, which will make it so we just call it .NET, but as of today, we still call things .NET Core, right? If you ever want to follow me, ask me more questions. David has definitely found me out there. I am out on Twitter. I try my best to respond to people, talk about AWS things. That's pretty much what I do. And so my main goals, and feel free to ask questions, and if we want to derail this conversation, I'm totally good with that one. But sort of the high level things that I was going to try to go is make sure people know how you can actually access AWS services with their SDK. What does that actually mean? What do you have to do for that? We've been diving a lot with like ASP.NET Core applications and how you build those in AWS. And so kind of then take a break and look at what it would be taking to add AWS services to a ASP.NET Core application and how you would deploy it. And then everyone's favorite topic is Lambda. How do you do serverless in .NET Core? So I thought we'd do some talking on that. So hopefully that sounds good. But yeah, feel free to ask questions as I go through. Tell me to slow down if I'm going too fast. Yeah, let's just see how it goes. Oop. Okay. So when it comes to accessing AWS services, how you programmatically access it, because generally when people are using AWS, that's either I just want to deploy my application and use it sort of hosting it, or I want to actually use an AWS services in my application code. And so that's where the SDK comes from. The SDK is made up of essentially a core NuGet package, which has, like, as you imagine by the name, all the core components. And then there is a separate NuGet package for every one of the AWS services. It's quite large, in fact. If I go to our repo, so most everything that I do is all open source. This is the repo SDK, and you can see, like, here are all of the NuGet packages we have for all of these services. Goes on and 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 on. So AWS has gotten very large, especially over my 10 years of being there. When I started there, there was about 12 or so services. Now we're at like 200 and some services. So it's definitely gotten a very large system. The basic pattern, the way that to use the SDK, you basically include the service that you want. Each package has like a service client object, which has a one-to-one mapping for all the operations of that service. And then you pass in a, it has like a kind of request response, like a programming model. So essentially, to create a client, you just have to give it some credentials and pick which region you want to go and actually connect to. So let's kind of take what that means, the credentials and region. So AWS regions, this is sort of my stolen marketing slide here. So there are regions all over the world. Interesting thing, difference the way how AWS thinks about regions is like each region is also then sub-broken down into what's called availability zones, which is basically a wholly independent data center inside that region. So it has redundancy. It's got its own separate power system, all that, but it has extremely fast network connectivity between all the different availability zones. So that's where we have these regions, but they have actually availability zones. So you have actually a lot of options for where your application is actually running at. Okay, when it comes to credentials, credentials are made up of an AWS key ID and a secret access key. Those are the two things that you generally need to pass into your service client to make requests. When you're on your dev station, you generally basically store those credentials in a credentials file with a name. I will show you an example of one. This is not my real one because I'm not going to show my credentials to everyone on the call. But yeah, basically you have a credentials with your accesses and secret keys. There's also more complicated ways you can configure things where you want to like assume roles in different accounts and configure MFA, all these different possible ways to get credentials into your application.
And Norm, could you bump up the text size on that?
Oh, sure. Okay. And be clear, this is not real keys, so don't try it. So yeah, when you're in your development environment, you're probably going to have a file like that set up in there. There's a variety of ways to have that configured up, whether you have credentials or you're having something that's feeding credentials to that file using assumed roles, however your company or group wants to manage credentials. Then when you actually deploy your application to AWS, you generally deploy it saying, I want that application to be using what's called the IAM role, an identity access management role. And that is where AWS essentially provides credentials to the application running in that environment. So, and that's where it's like you can lock down permissions, and you can lock down permissions on the development one, but you can lock down permissions. You can, the keys are always, or the credentials are rotated all the time. And under the covers, the SDK will just manage all that for you. So you don't have to really think about that for the most part.
A quick question I have on that, Norm. I take it it seems like most of the libraries just pull from the instance metadata that's available locally, at least on an EC2 instance. Is that considered to be the primary way of pulling any of the IAM information through the libraries?
Yes, I mean, yeah. So yeah, EC2 has its thing. It's called instance metadata. Yeah, where basically that's where the role credentials are assigned to. The SDK will automatically go find those credentials for you, unless you explicitly set something differently. In other services that we have that do deployment have a mechanism like that as well, to do that. So I think actually my next slide is how you find it. So, so yeah, the SDK has a whole search algorithm for finding credentials. Most important, like if you are explicitly setting credentials on the service client, then it's always going to use those by default, because that's where you told it what to do. If you didn't, it has like this whole series of checks it goes to look for to find which credentials to actually run your application. If you're .NET Framework, it'll go check the app config file to see, did you specify a profile you want to use? It will also go look to see, is there a profile that happens to be named default, or is there an environment variable named AWS profile with a profile name? And if so, use the credentials for that. You can also explicitly set environment variables for the access key and secret key, and we'll use those. And then the final thing is it will go and look to see, are there credentials assigned to the environment, like the instance metadata that you talked about, David, or the role assigned to a Lambda function or to a container environment through one of those solutions. Okay, so I thought to get an example of the coding, I was going to take a look at how you do coding for S3. Probably many of you have probably heard of S3. It is the very large object storage service out there that has huge amounts of durability. Pretty much if anyone is streaming anything or anything like that, you're probably pulling things from S3. I know Netflix is there and Disney Plus is there. Obviously Amazon Prime is there. So that's where so much of the internet is basically pulling things from S3. You can store objects from up to 5 terabytes. And the basic thing is you're creating objects and you're sticking them in buckets in there. So that is the truly simplistic view of S3. Let's take a look at what it would be to actually code for that. So I'm going to switch over to Visual Studio. Here is my exciting project all ready for us to start coding. Because I was going to attempt to do live coding while everyone is watching. What could go wrong, right? So I've already added the NuGet package. So this is our NuGet package for S3. And we're going to do .NET Core. So first thing we want to do is create a client. S3 client. And I'm going to specify the region. So I didn't specify credentials because I happen to have a profile on my machine that's called default. So it'll automatically just use those. The nice thing about not specifying the credentials here then is, so when I deployed this code to AWS, it'll then use that same search algorithm to go find credentials, and it'll automatically pick up the roles associated for my account. And so S3 lives in this namespace, the Amazon S3 namespace. And sorry, I'm looking at my cheat sheet. So, so now we have a service client, and like I said, you would need to go create a bucket to put that in. And I can say, put bucket here, or not put object, put bucket here to go create a bucket as well from the SDK. You might also notice I do have this AWS Explorer over here. I can actually go create a bucket right here. So in my Visual Studio, I'm going to say I want to create a bucket. And I'm going to say Norm J. Dallas is my name of my bucket. So that's my bucket to go start putting data into it. I'm going to just.
So Norm, when you created that so I take it that created it in your account, and do you have a configuration for the defaults that you use, or are you able to have a configuration for defaults that you would use on that, like saying requesting a specific kind of encryption or KMS key or something else like that, or does it just create it with all the defaults that you would get by just saying, like just clicking next through the wizard inside of console?
The console does have more features that you can specify on there and policies and defaults. The toolkit does not currently have that feature. So if you want to go through there.
Thank you.
So let's think about how we'd actually create an object. So I mentioned like the SDK basically works with like a request and response pattern. So first you would create a request. So this is my put request to say I want to put an object. I have to spell it correctly. It's one of those rules. We specify our bucket name. I'm going to create a variable key. This is going to be my simple object text and key. So this is going to be the key of my object. So because when you create when you put an object in the S3, you're identifying the bucket you want to put its unique key in there. This is what you're going to grab it in, which is often a file name. It could be any UTF character or string of characters. One thing that does often trip people up, they think of S3 as a file system because it is generally the easy way to present that in a console. We do that all the time. But it's really not a file system at all. It is just a pure object storage. It's like key for the object. It's just like you'll see in tools, they'll just have conventions that if we say foo bar, those tools will basically do make it look like file systems based off of the slashes in the keys. But keep in mind, it's really not a file system. It is just a very large object storage. And then actually put some data. There's a stream. We can just pipe a stream into there. We could point it to a file path, or we could actually just say, here's the content body of saying, we are doing it live. But that's essentially it. There's a few other properties, as David mentioned. There's some encryption settings we can turn on to do server-side encryption or customer key encryption. You can also enable an event callback, so if you want to get the progress updated as it's uploading that object, you can get those events as well. You can tag your objects, but I'm going to keep this demo simple and just say await S3 client, put object, and put requests. And that's essentially all it takes to upload an object to S3. If we run that, that should. And again, it's not a file system. We just like to make it look like one. There's our object. So overall, pretty simple, I think, to put objects in there. To get an object out, it's very similar. So really, once you learn that pattern, you understand the whole SDK. So to get out, we say get request, get object requests, bucket name, key name, Not new. S3 client, get object. So now the get one is slightly different than a lot of other responses that come back in the SDK, in the fact that it actually, and I'll actually spell it correctly. It actually returns back a stream to the data. Like normally you're getting back an object that represents the request and you can just manipulate that. But here's the case, you're actually getting the stream to that object in S3 that you would then read from. Because we have that stream, you do actually need to dispose of it, right? That's why I have the using in here to say that we need to dispose of, we need to close that stream when we're done with it. So, but other than that, you can just do new stream reader. And that should basically, we'll put an object and we'll get an object back out. So there we're doing it live in code. But yeah, again, you'll see like I showed we have like those 200 and some service packages out there. They're all using that same pattern. There's a service client, takes in about the same parameters, create a request object, and you'll get a response object back. You know, the put object had a response as well. There's just not a lot of interesting things on it. For some reason, I'm convinced that there's no P in response.
All right, 3 things, Norm.
Okay.
2 questions and 1 request, if you have it. So the request is if you have some material over explaining IAM for new people to it later on, that could be useful. 2 questions. One from Chris Bernard. His question is, not Bernard. Sorry, Chris. My fault. One is, how do you create like those URLs that can like use only once URLs with S3? Because he was thinking that you could do that with S3. Is that if that's a feature of S3 and you've got a quick demo for that, that'd be cool. The other thing was from me. I was looking earlier today, actually, trying to figure out how to get just the number of keys in an S3 bucket. If you happen to know that and want to be my tech support, and I'd love to see a demo on that.
Okay, so for number of keys, there's no single, you basically have to list the objects.
Yeah, that was, okay, that's what I found and what I was trying to avoid. All right, good to know.
There's no, I mean, it comes back to S3 being its scalability. Like if it had to actually keep track of one atomic number and keep that in sync, that's problematic, right? Because there's customers. Again, we talked about Intuity. Like they're huge users of these things, and imagine all the stuff going to S3. It just goes so fast. It just doesn't scale to have a single number for that. So that's why, you have to list it.
Good point.
I was going to do a demo on what you asked before, which was the pre-signed URLs. I think is what you're basically saying. I want a URL that I can pass on to somebody. The short-lived URL. It's not a one-time use. It's a short-lived URL.
Yes, that'd be great. Thank you.
Yeah. So let me do that one. So to give clearance or more feedback to everyone else, like a common use case what people will do in S3 is like they might want to just hand a URL off to somebody else that gives them access to the object, or imagining you want your backend service to be able to pass down URLs to like your images to your front end client, something like that, right? So you'll have the server generate a bunch of pre-signed URLs that the client can use to get those. So you're not actually using the SDK to get that. So here we've got an object up here. If we want to go create a URL for that, we can say S3 client, get pre-signed URL. So here we're just going to say my bucket name is still the same bucket name. My key is the same key. The verb I want to do, because you could do this for all the different operations, but here we're just going to do a get. And you want to say how long it expires for. So we'll say this expires and we'll say an hour. Okay, so let's print that out. So if we run that, there is our very long URL that you can see. This is basically what happens when you make a GET request. It contains the full path. Here's the bucket name. Here is the resource path to the object. And this is all the rest of this is the signature that gets added on there to verify that you are the right user and that has access to it. So we can just take that and go there, get the same object. So there you can imagine you can write your backends, whatever, generating URLs and passing those down to your clients, or somehow passing around the information to other external sources for that. So.
All right, another question, also from Chris. Can he show object metadata since the S3 docs say you have to send them in X AMZ meta headers? I imagine that it's in put object request via a dictionary of string or something like that.
You want to know how to
Hey,
add
Chris,
metadata?
if you want to jump on with your mic, I don't know if you have that today. Oh, let's see. Oh, he doesn't. Let's see. He does not have a mic.
Using metadata.
If you look in the comments, you'll see a link to what he's talking about.
All right. This is. All right, so let's see. Object metadata.
The user-defined object metadata section.
Okay. So if I understand correctly, we could do metadata. Just do this different. Put request metadata. Add demo live. I'm sure this will work. Okay. We can add that there. So then, instead of getting the whole object for that, we could say var get metadata response. I swear, I can't put a P in that word. S3 get object metadata. Oh, too many things. Okay. And so that should contain, if we did this right, and I'm not completely crazy, okay, so again, following the same pattern, creating a request, getting the response, we call it get object metadata. And if that should work. Oh man, I'm gonna be called out. Demos were going too well. Oh.
Demo gods always win.
I forgot. Yeah, the SDK tries to be a bit smart for you because metadatas have to, the header actually has to have the XAMZ metadata. So it does slightly change it on there.
So when you put your name on it, it'll translate it, it'll transform it to the standard header that AWS has, so it doesn't translate it back out for you.
Yeah, basically, yeah. I mean, all the headers have to be lowercase, and any metadata basically has to start with XAMZ meta. That's how we know to put it in that, or S3 knows. So the SDK is saying, okay, go ahead and translate anything that you give us and make sure it's in the format that you can actually specify metadata. So that will, I'm sure, surely work. There we go.
All right, thank you.
Yeah.
That's what I wanted to see.
Yeah, so to make sure everyone knows, like the difference between get object managed, because I could have also gotten on the response has of the get object, that's got metadata as well. The difference here is this call does not send the object down. So this is like, maybe it's a 1 terabyte object in S3. I just want to get the metadata of it. You would say, go give me the metadata of that object. And I'm not paying to download the whole object for that situation. Just getting the, under the covers, what that means is this is an HTTP GET, and this is an HTTP head request on the object. So. So the last thing I wanted to talk about with S3, I mentioned that this can be used for storing very, very large objects. You know, a 5 terabyte object. You probably don't want to just do this simple of a request for a 5 terabyte object or something very large, right? Because the chances of something going wrong, some network blip happening, and then you have to restart the whole thing is not what you want to do. So what S3 has is the ability to basically upload an object in parts. I'm not going to write all that code. Here is what that code looks like if you use just the service client, where it says, basically, I want to start a multi-part upload. And you can see, again, the same sort of pattern. You create a request, you get back a response. You say, I want to do that. You basically break up the object in whatever parts you want to. I think that the minimum size of a part is 5 megs, except for the last part. The last part can be whatever it needs to be. But you break it up into 5 megs, you upload all those up, and then eventually you complete the multi-part, passing in all of the E tags, which is like essentially it's the MD5 checks of the object in there, so that it knows to basically S3 will combine the object up there. So, and if something fails and you want to do, you could abort the thing too. So this is the whole code it takes to write a multi-part upload, and you could customize this in whatever way you need to. But there is a much easier way to do this. So you don't have to write all that code, because it's important. The service clients are always meant to basically be a one-to-one mapping of the operations that the service exposes. There are a few cases in the SDK where we decided to put some high-level abstractions to kind of simplify some things. So if we go back over here, we have a utility class called transfer utility. And you pass in an S3 client. And that's got a upload request object. You can say transfer utility upload request. It's pretty similar to the put object that we just saw. And here you can put input path, or you can put file path to some really big file.bin, which I don't really have that. So then now on the transfer client, you can just say upload. And what this code is going to do is all that code that we just saw before it'll basically do that multi-part upload, and it will use extra tasks to sort of parallelize that upload for files. If the file is of a certain size, like if it's still a small little bitty file, I think by that I mean like something like less than 16 megs, I think is the cutoff, then we'll still do the regular like put object up here. If it's not, if it's something bigger than that, it'll say, oh, this is a big object. Let's switch to doing this, this whole version up here, except it, has much more parallelization code in there. So in general, I would actually recommend whenever putting objects in S3 is to always just use this class, and it'll figure out whether it should do a multi-part or not. And that way, like if you're trying to upload something big, maybe one of those parts has a network blip or something that happens, the SDK itself and stuff will basically just like, let's just retry that one part. The SDK itself has built-in mechanisms for doing retries and handling sort of network blips and things like that. It's much better to retry on a 5 meg part than a 1 gig, object. So highly recommend basically always to use that. It is in the transfer namespace in that same NuGet package. But other than that, the code is pretty similar. There's also APIs for uploading directories as well. And you can also do a git as well. So, but yeah, that's really kind of what I wanted to show from S3 and then how to use the SDK. Does that sort of make sense to everyone? Get a rough idea what we're talking about?
Yeah, that's great.
We had oh, go ahead.
No, I was going to mention that question, but no, that's a great demo. It's very helpful. Go ahead, Justin.
Oh yeah, we had a question here. Does the transfer utility, someone recalls, had a limitation where the stream needed to be seekable? Is that still true?
Yes, it's that's just in the put object as well. The way S3 is designed, it always has to know the length of the object, and we have to be able to sign the requests as well, which basically means we have to kind of do a SHA-256 of the object itself. And so in that case, it does have to be seekable. So it is one of those things that I know many people wish it didn't, but that is the S3 design. So it's not an SDK issue. It's just how S3 is. So the usual way that people do that for very large objects to get around that is they will do like the multi-part upload, and just keep adding parts and parts and parts. In memory, like store that part in memory up till it knows that. And then eventually complete when it has all of the parts uploaded is what I've usually seen.
It's great, Norm. It's Augusto here. Quick question. If you had an upload happening from the browser where you have a backend, let's say any React or any SPA application trying to upload a file to S3, what would be the steps to do the same multi-part upload? Because you wouldn't want to upload that to your server, to your web API. You would want to upload straight to S3 from the browser. So how would that flow work?
I don't know if I know that is something that people do. I don't know if I personally know the great way that is solved. I'm a little nervous throwing something out because I don't think I'm going to give the greatest solution.
It's kind of like having a signed URL that you can upload the multi-part file, so that you don't have to go through your server. Let's say you have a Elastic Beanstalk app. You don't upload to that server, and that server then sends to S3. Ideally, you would send from the browser to S3 in one go.
S3 does have a protocol that we have not implemented yet in SDK because it's sort of a side part where essentially you can generate SIGV, basically the pre-signed URLs. Well, actually, yeah, I know the JavaScript SDK basically has capabilities that you can use to go and generate a pre-signed URL, then use that to upload to S3 from there. Is what I know. Yeah, I'm sorry. I feel like I should know this answer, and I'm worried I'm going to tell you something really bad. So um,
Mhm.
I know there are reasonable solutions, but I haven't done it myself, so I don't think I'm quite the right person to answer that one. Although I understand that the common use case does make total sense.
Right. Thanks. Yeah, the use case is to have the API generate the URL, right? So the client doesn't have any knowledge of the buckets or anything. You
Right.
would call your own API, right, and say, hey, I want to upload a file. Give me what I need.
Yeah, and I think from the SDK's point of view, you could you can do. I think you can do that. Create the pre-signed URL that we did here, and put do the put as well. You just have to make sure that like the actual object key you want to push it to, and I think if there's extra headers you're going to pass into it, you need to basically pass those as well. And this is where, like, I know you can do it, but I'm worried I'm going to tell you not the complete picture. But this is where I would look into how you would do it. So have a web API that generates the pre-signed URL, pass that down to the client, and then the client could send it there. Otherwise, yeah, you are sending the whole object to your web API, and then you have to essentially buffer it somewhere over there so that you can know the content length to send to S3, and that's where you might want to do it as you buffer it up to a part size and then send that part over to S3.
Okay. Thank you.
Yeah. Okay. Were there any other questions? Thanks for helping me keep track of the questions there.
Good so far.
Okay. All right. So that was the SDK, and then I use S3 for that. Now I want to talk about like some of the stuff we've been doing to make ASP.NET Core applications lives easier. So to be clear, so AWS supports .NET Framework is fully supported. There are many people that work on making sure that stuff has great features. The SDK works for .NET Framework. We actually still support the SDK .NET Framework 3.5, which, as much as I would like us to be able to move past that, there's still a lot of people that use .NET Framework 3.5, and so we still support them. We have services that do just actually run .NET Framework applications. I get the pleasure of mostly getting to play with the new hotness stuff, and so I try to make the .NET Core stuff and all those things that work as well. So I've been focused a lot on ASP.NET Core. So here we're going to talk about how, now that we know how the SDK works, how we can actually integrate that inside the ASP.NET Core application. Talk a little bit, one of the great things about ASP.NET Core is, unlike ASP.NET Net, it actually was built with a lot of good extension points. So how we can plug in AWS services in there. So I'm going to talk a little bit about some of those extension points that we've actually connected to, then how we can do some deploying of ASP.NET applications. So that is the extent of my PowerPoint slides there. Let's go back to coding. So if you haven't figured out, I'm not much on PowerPoint slides. I like to really just spend most of my time looking code. And that's why it's great. And I really appreciate people chiming in and telling me what they'd like to see. So I will try to do it. But so here is this brilliant application that I wrote last night. And it shows off my amazing skills at UI. So it is my translation site. So I can say, happy birthday, Russell, because I hear it's his birthday, And we can translate that. And so currently our translation is we just reverse the letters. Not really very exciting. So what I'd really like to do is, translate that to different languages, which you can guess there's an AWS service that handles language translations. So let's take a look at what it would take to get this application to do that. So first, we're going to go add a NuGet package. We're going to add the AWS SDK translate service to our project. And you will see it's going to have pretty much the same patterns as we talked about. Now, if you have been doing much ASP.NET Core development or any .NET Core development, you know there's the whole dependency injection framework using the service collections. And so we have made some ways to basically integrate the SDK into that experience. And that means that we're going to add yet another NuGet package. We're going to add the AWS extensions for .NET Core SEP. And you can blame me for that terrible name. I'm just going to say that naming is hard. So I do believe it is the hardest job we have, is figuring out what to name things. So now with that package in there, we can actually then say services, add AWS services, and add translate there. So now our service clients will be actually integrated into the dependency injection system. And for that to find credentials, it'll use that same sort of credentials mechanism and look for like the default profile. But I can also specify in my app settings file, whether that's, you know, the normal one or the development, I can say AWS, and we can say region equals US West 2. I could also specify a profile. I'm not going to, because I would rather use the default one I have. So now, if you look at our page, we can actually start now using our new service. So we can say Amazon translate client. And so here is the very sophisticated translation code we've got right now. We want to make this a bit more realistic. So, and I should mention too that in the SDK, when it comes to .NET Core, all of the operations that actually make service calls are always async only. The difference between the .NET Framework flavor and the .NET Core one, so .NET Framework supports both synchronous and asynchronous. For .NET Core, we kind of wanted to follow what was the patterns that Microsoft was pushing, as well as the HTTP client only supports async operations. Although I think I saw they were going to add the sync operations in .NET 5. But we are supporting just the synchronous ones. So we're going to say our request is equal to, and I should say, so the way I usually do when I do look for stuff, I will start at the docs page. And I see, okay, let's find the translation service. Go to the developer guide. Here's our API reference. And there's our operations that we have. So you can see, basically, this is the request and response. So this is what we want to specify in here. This is my usual way of navigating it and figuring out which is the right way to call AWS services. And I will say, okay, I want to do translate text requests. And our text is going to equal our source text. Our source language is equal to EN. And we'll say we want to go Spanish. Then we can get our response. And then set our translate text. Okay. So in theory, that's all it should take to then add a real translation to our service. So now if we run this, and now we really wish Russell a happy birthday. We get it translated. So this is kind of how you can see we kind of integrated the SDK into asymmetric applications. And it doesn't have to be asymmetric core. Anything that's using the dependency injection framework of .NET Core can easily just pull in that extensions package here and be able to go in and then basically add services there. It'll take care of creating the client, pulling in the configurations out of where they need to come from. And I should mention too that when we create clients here, it's actually creating it as a singleton. So all the service clients are thread safe. So you can't just create it once and then just reuse that same instance over and over again. They are thread safe that way. So what I wanted to mention now, and I'm gonna cut this part a little short. I was gonna demo how we could add logging into CloudWatch logs, but I wanted to save time for the Lambda stuff too. But this repo out here, this is our AWS.NET repo. This is the one that kind of lists sort of all of our .NET packages out there. So you can see here's that library we just talked about. There's the SDK. We have libraries for integrating logging in there. So like this basically takes, nlog or log4net or Serialog or the ASP.NET Core logging. You integrating any of those logging frameworks to basically you use CloudWatch, which is the service inside AWS to monitor metrics and logs and events and things like that. So we can basically use that as a source or excuse me, a destination for any of the popular .NET logging frameworks out there. So .NET, for the ASP.NET Core one, it's pretty simple. Basically in the logging, you need to specify the region and what log group you want to use. And then in the program CS file, you can add a configure logging and add the AWS provider. So we have a few of these types of libraries to kind of make life a little easier for you. There's, if you want to have Cognito be your identity provider, Cognito is AWS's sort of standard way of doing identity. You basically hold your own user pools for users. It connects to social media sites, and you can basically hook that up as the way for ASP.NET Core to do its authentication. If you want to store configuration outside of your system, like you probably don't want to bury it in your app settings file, you can use this library, which essentially adds yet another builder inside the configuration builder, and it pulls configuration data from Systems Manager, which is one of the AWS services that you can use to store configuration data. So yeah, definitely check this out. Check this repo out there to see what some of these things we kind of tried to solve these for you, so you didn't have to re-implement them. So, but I kind of want to talk about a little bit how we can actually deploy this application. So this is your standard ASP.NET Core application. If you're using the toolkit, you can actually just right-click on here, and I say I want to publish to Elastic Beanstalk. This is one of our deployment services. Beanstalk basically has an application, and an application has a collection of environments. So I'm going to say I'm going to create a brand new application using this profile and on this region. Create a new environment. This is going to be my test environment. So this container basically, there's Windows Server containers, and because my account will probably show more than anyone else should ever see, because my account has extra permissions. But basically, I mean, you're seeing all of the older patches. You're not seeing anything terribly interesting here, but you can see extra patches of things. But we have Linux, being able to play to Linux, Windows servers, core, or the full desktop, 2019, 2016, back to 2012. But we're going to deploy this to Linux. So this, when you do Beanstalk, it's actually going to provision you an actual EC2 instance, which is the virtual machine technology that we have at AWS for running things. You actually will have full access to that machine. So I can specify a key pair on that, which would actually give me access to SSH right into that box if I needed to. You could also say, I don't want any key pairs on there because I want to really lock down this machine and make sure no one has access to get in there. Up to you. You can say, like, this is a simple, like, I just want to deploy this as a simple dev environment to see what it looks like, and just say create a single environment. Or I could say I want to create an application load balancer and get it, multiple instances behind it. I can do rolling deployments, a lot of things that you can do for that, but I'm going to just leave everything at their defaults there. And so this is where we kind of we've talked about roles a little bit. And so a role is basically what's going to give my running application access, because we saw I didn't specify any specific credentials for my service client. I just said basically create a client, find credentials. When I'm running in Beanstalk, it's going to find the credentials for this role that I'm going to use. I'm going to use my Beanstalk demo role. That role has a number of policies put on it, which says basically what actions you have access to on that. So you can really kind of lock down the scope of what's actually available for this applications to do with AWS. Which next? Say we went to release build. For .NET Core, you can say I want to do a self-contained deployment. So if for any of you that want to try .NET 5, .NET 5 is not currently baked out into Beanstalk. It will be eventually when that launches next month, and it'll probably show up on Beanstalk usually about a month after that, just depending on the release schedule. If you want to get started sooner, you could just say I want to do self-contained deployment for .NET 5, and then that would work for you. You could enable X-Ray. X-Ray is a really good service for when your application is connecting to a lot of different endpoints. You can basically have it build a service graph of everything that it's connecting to. So if you're like going off and making other AWS service calls or things like that, you can kind of build these graphs and see where your latency is and see where your errors are coming from. It does require a little bit of instrumenting your .NET Core application, but it's pretty minimal. It's basically, like register the SDK type. So that's not it. Somewhere down there. Yeah, ASP.NET Core, you basically say, I want to use X-Ray and where you want it to fit in the HTTP stack. So pretty minimal instrumentation you have to do to turn that on, and definitely give you some good diagnostics information in your application. I'm just going to skip ahead, and we're just going to say deploy. So that's really what it takes to deploy. It's going to go build our application, essentially uploaded it to S3. You can see that's what it is doing there. And then telling Beanstalk, go create an environment based off those settings in that zip file we just uploaded to S3. So, and this takes about a couple minutes to turn on. So while that's going, let's look at some of the other choices we could do. So for other deployment options, we talked about Beanstalk. You can definitely do that one, as we just saw. You could also just use EC2 directly if you wanted to. Maybe you've got your own scripts you have for deploying out there, or you could use AWS Code Deploy, which is another service that you can use to sort of orchestrate sort of deployments. And there's a lot of controls on that for, like, depending on how you want to roll out your deployments, how you want to do maybe some blue-green deployments, rolling deployments. Has all those capabilities. There's a few options on if you're doing containers. ECS, Elastic Container Service. This is AWS's own container orchestration framework, or is that a right word? Service. You can use that to roll it out there. or you can use Kubernetes, whichever one you prefer. I'd say the difference is, Kubernetes, you're basically, you're using the, sort of the open source tool. It's more de facto if you want to go with in the container world. But if you want a more ECS, will give you a container service, has a lot of the same features that most people need. Depends on what you want to do. I'm not trying to say one is better than the other. I just want to say, like, if your application, if you're kind of in the light stages of containers, ECS is probably where you want to go, because it's actually a lot cheaper to run that service, because you're not running any control plane or anything like that, which you have to do with Kubernetes. And here, the control plane is all part of the service, and it can be quite a bit simpler and easier to run. But if you are ready to basically run in your own Kubernetes cluster, which, and we take care of a lot of that with the managed cluster, but there is definitely the Kubernetes management out there. Both of those services have two different ways you can run your container applications. You can either assign EC2 instances specifically to those clusters, and then the orchestration engine will figure out where to put the running containers based on that. Or you can say, I want to use Fargate. And Fargate is a technology AWS has that says, basically, when I want to go deploy, run my container, just say it needs X amount of memory and X amount of CPU. And then it'll just automatically take care of providing the compute power for there. So in that case, you're not in the business of managing any EC2 instances or anything like that. So it kind of just depends on which way you want to go, which works for you, best for you. There's also a batch service if you have a big batch processing sort of work you need to do. That takes care of all your queuing of things and controlling how that goes. And of course, there's Lambda as well for running things as well, which typically is running for more microservices based architectures, but you can actually run ASP.NET Core applications as well on Lambda as well. So, and I stalled long enough so that now we should see we are now deployed our application now to live. So we are live in the cloud. That translates to that. I don't know Spanish at all, but so I'm just going to guess that that's all right. So, okay. So that
a quick question on that. I'm going to guess that the translate service is charged per translation, per size of translation. I imagine there's some. I hadn't even looked at it, but now I'm like wanting to Google it now. I hadn't Googled it either, so, and you're doing it for me.
Yeah. The nice thing about working at AWS is I just get an account that gives me access to these things. So I always forget to look at these things. So,
characters per month and other things along those lines.
Yeah. Okay. Yeah, I don't know the pricing. I'm gonna skip on that one. It's somewhere.
No, that's okay. Yeah. It was just a.
I would imagine it's like usual things of like there's a certain amount of free tiers, and then and a charge per X amount of requests, batches, and things like that.
Yeah.
And I saw the Translate had service features for doing larger translations that can be done more in batch mode than the synchronous one that we were doing here. So I actually was just last night trying to decide what should I demo, and thought, hey, I've never used Translate before. Let's do it. So you all now know as much as I know about that service. So okay, so let's talk about Lambda. So the serverless.NET Core. So if you haven't used Lambda, I know some of you said you had, but just to kind of give a refresher here. So Lambda basically, it runs your code, in our case, .NET Core code. You don't have to manage any servers. It's an event-based compute power system, right? So it's not like EC2 or containers where it's always run. It's basically just, it's providing the compute power as the events come in. And that's kind of how it does its scaling, because it's just scaling based off of the events coming through. Those events can come in through either S3, or any service events. Many AWS services have ways to basically hook up a Lambda function to cause when something happens. You can also have HTTP events coming in from API Gateway, which is our service out there to sort of make REST APIs. You can also hook them up behind a load balancer. I would generally say people do the load balancer when it's like, I already have like my application on Beanstalk or EC2, but I want to essentially say part of my application I'd like to be serverless. So let's put some of my Lambda functions behind the same load balancer that's serving my application. That's definitely a very common use case. You can also just do custom events. In the SDK itself, you can, like we've seen before, you can grab the Lambda SDK and you can call the invoke operation there. And Lambda is going to scale basically on the events that you come through, So this is my slide that I kind of have that gives the 10,000 foot overview that of how Lambda works. So hopefully that kind of gives some clue here. So what we're talking like here, like imagine on the right side here, this is the Lambda environment. And an event comes through. This is maybe a service event or something like that. What Lambda is doing under the covers is it's saying, oh, okay, let's go spin up a compute environment. Now, all that is under the covers for you. You're not thinking about anything. That you just know that someone has sent an event and it's going to run your code. And so Lambda has spun up that compute event. And that's what you're here is that cold start where we'll actually spin up the cold start for this process to be spun up. And it'll process the event. Once it's done, if there's no other events, it basically freezes that compute environment. So it's stuck there to see if another event comes through. Then a second event comes in, and Lambda's like, okay, I already have this compute environment. Let's just use that one, and it will go and send the event there. And that's where you get your continual warm starts. On that. It'll go back and freeze after it processes that. Now imagine we get like 2 events. And so this is where the scaling of Lambda comes into play. So 2 events come in. The first one basically goes to that same first compute environment, but Lambda's not going to let that other one just sit there. For the most part, it's going to say, okay, well, we got to make sure that one is being processed. So since there's not an available compute environment on there, it's just going to go spin up another one. And it'll process that one. So this is where Lambda is like this hugely horizontally scaling system. So it basically handles all the events coming through at that time. Once, if those done, those are both frozen. And if nothing else comes through, if no other events are coming in, it'll eventually, Lambda will basically say, okay, let's just remove those compute environments because there's no inactivity. Now, everything that you saw in here about those compute environments are not things that you have to think about when it comes to that. Unless you get into, there's a feature that was launched last year at reInvent. This slide actually was kind of old, so I should update that. Where you could say, I want to always have a certain amount of compute units always available. It's the provision concurrency. So I could have specified I always want 2 around. But in general, if you're not doing that, that's how it pretty much works. So for .NET Core, so Lambda in general always have a policy of supporting LTS versions of language runtimes. So that means for .NET Core, that means we have 2.1 and 3.1 out there. You can use .NET 5 if you want to do, but you have to do a self-contained publish, essentially is how it works. We have a feature out there called custom runtimes, which allows you to do that one. My one caution, if anyone comes off this call and says, I want to go try that right away, is we did find a bug that Microsoft has fixed with the .NET RC1 that is causing it to not work in Lambda. So we have verified it's fixed in the upcoming RC2, but you can't do the custom runtimes with .NET 5 RC1. Okay, so that was my talking time. Let me take a drink of water and we'll go do some more demos.
All right, while you're drinking your water, a few questions have come through.
Oh, great.
First of all, how fast is it on a cold start up for .NET? Like, could you put in a Slack bot and get a relatively instant response? Also, does that kind of webhook require the API gateway?
So cold starts vary greatly depending on basically what you're doing. How much code you're doing during the initialization stuff, how much of that you can defer later on there. I will admit that .NET Core of all of the Lambda languages is on the slower side of the cold starts. I think .NET and Java, all those sort of the runtime requiring a virtual machine is on the slower side. The good thing is .NET gets faster and faster, and they're getting more and more into. I think a large part of it is the jitting that happens in .NET. If like basically that conversion of the IL into the machine, the machine. So that is the largest part of your cold starts. Microsoft has been making good changes on making that better and better. I'm excited about also with .NET 5, they added a lot more trimming features. I don't know if you've read those blog posts where you can basically trim down your deployment bundle. So that gets that I've seen in my sort of testing around, which hasn't been exhaustive, but in my testing around, I've seen some pretty good changes with that when using custom runtimes. But yeah, largely depends on what you're doing. You can always improve it by, the easiest one to improve it by is basically, and I'll show this in a minute, like there's a memory setting that says how much memory I want to allocate to my Lambda function, which is like one of the worst named properties, because really what that is it's like, this is my vertical scaling bar, and it says like how much CPU power I want to put on that. So if you find the cold starts don't match it, you can say I want to increase the memory, which doesn't necessarily mean you need more memory, but it means you also get more CPU power, which will also speed that up there.
Another question. For someone who is very familiar with .NET, but is new to AWS, do you have any suggestions on drills / exercises / projects that one can start with?
I have this one. I'm curious, and if anyone is, so I basically sort of have two talks I've been doing lately. Well, this is one actually I'm making up as we go. So hopefully today's going well. I have another talk I do, but it was meant to be sort of a workshop. So this is something I built. I can put the link somewhere. Yeah, the chat. This is something I wrote, so this is not like an AWS thing. This is something it was basically using .NET Tries sort of capabilities to make sort of an interactive workshop going through and building a serverless to-do list application. And it kind of goes through some of the stuff that we covered today. Usually it takes me, when I do that talk, it takes me about 2 hours to do. Kind of cool to do though. I know that there are they just released a bunch of YouTube videos as well. Let's see. We're all going to look at my YouTube or my Twitter. Hopefully there's nothing terribly exciting on there. All right, Josh Hurley, he's one of our developer advocates, and he tweeted and I retweeted not too long ago. It's on here somewhere. There's a bunch of videos here. This is essentially our playlist of YouTube videos of all sorts of things you'd want to do with .NET and AWS. I'll put that link out there as well. So.
Thank you. That's great. Another question. Will Lambda support AOT compilation for faster starts in .NET Core /5? If so, what would be the platform to target?
So compilation would be done. I mean, that's more of a how you build your deployment bundle that you send to Lambda. So if you do that build beforehand, then because Lambda is just taking the binaries there, so that it's not doing building. So .NET 5 is not an LTS, so it's not planned to be a managed runtime. You would do it as a custom runtime, so you could definitely use those features there. So one of my mini jobs is working on the Visual Studio and the Lambda tooling, and I do try to include as much of those features as possible in our tooling. So I'll show a little bit. So here is basically our command line tooling. I am a big believer of taking advantage of Lambda's tooling mechanism of using the .NET tool, install whatever tools. It's a good way to distribute our tooling, as well as the Visual Studio. And so this is what we use for Lambda, which is StartNet. You install that there. So I generally try to put whatever tricks I can into that tooling to optimize things as far as packaging bundling. So when Microsoft comes up with new ways to compile things for pre-jitting and stuff like that, I will find whatever ways I can to get it in there and make it a smooth experience.
And one other final point of clarification. What you were showing us earlier in the evening about how the profiles worked and the credentials and all that, that applies to every single SDK thing you're doing, right? That applies universally. It always does that same lookup from explicit.
Yeah, I mean, because of the SDKs all starting at different points in time, there's some slight inconsistencies here and there, but for the most part, yeah, they're all having that very similar pattern of searching for credentials.
All right, thank you. No more questions.
Okay, let's see if we can do. I think we're going to try to do a Lambda demo here. So
no more questions for now.
Okay, so in the toolkit, we've got quite a few blueprints that we're going to use. So I'm going to just create one now. So we have, so I'm going to say Lambda. So Lambda, we've got blueprints for C#, F#, because I do try my best to support the S# community, even though I'm not a great F# developer. I do try. And so I'm going to create a Lambda project with tests. So let's see what that is. Let's see, this is project number 1. So he's just going to bring up a collection of blueprints that we have. Basically, here's the pure empty one. I don't want anything in there. There's some that are set up already to start listening to service events. I'm going to do this one because it's kind of a full example that we can just kind of take a look at. So what this blueprint does is basically, it is a blueprint that listens to events coming from S3 and sees, and basically we're going to do image recognition to see what's in the image and put some object tags in there. So it's kind of a sort of simplistic demo, but it's going to give us enough pieces in here to show what we're all doing in here. So this is basically what a Lambda function that looks like. You will create generally you have a constructor, which has no parameters because Lambda is going to go create that class for you. This is where you can sort of do any of the initialization work that you want to do that lives in for the lifetime of that compute environment. If you remember that previous slide, the squares, the compute environments, like as long as that process is alive, everything you do in here would stick around because basically the instance of this class is being held on to. So it can save you work there. So we're going to go create some service clients for that. You can pass in environment variables as well when you create your Lambda function. So it's a way you can pass in configuration data. So here, when we're doing our image recognitions, we're going to say, I only want labels coming from there that we have a reasonable amount of confidence for.
So Norm, if you have something initialized in a static constructor for this, is that going to stay? How long will that stay resident? Or is there any kind of timetable for that to stay resident?
It stays in for the length of that, however long Lambda chooses to keep that compute environment around. So, imagine essentially that compute environment that we saw, these cubes, like This is a
Okay.
running .NET process, and it'll last as long as it thinks that there's still reason for it to keep it around. Once that's gone, then everything in that memory is gone.
So then I mean, your cold start, your really cold start is, will take whatever time it takes, but each time, like if that's something that gets created and it stays active in memory, it's not going to, it might recreate a new function instance, but it's not going to reinitialize that. Yeah.
Right. I mean, there is like at some point in some amount of time, Lambda is going to recycle those compute environments. But for the most part, if you have a steady amount of load, your cold starts should be minimal, because you're just always hitting warm start situations. So I have a second constructor here. The reason is like my recommended approach for people how do you test these things, is basically to create your own test project. And in my test project is where I'm going to say, use that other constructor and run the code here. So that, because really there's not a lot to the programming model of Lambda. It's basically construct your object, and then you have a method you're going to call. That is essentially the whole programming model of Lambda. And that's always been the goal of Lambda, is to keep it a super, super simple programming model where it's just, tell me what piece of code to call. And that function generally takes in an event object. In this case, it's an S3 event. Now, natively, actually, Lambda is always working with JSON documents for taking in the request. If this could return back a response, like if it's from API gateway. And how we're getting an S3 object in here is because at the top here, we registered a serializer to say to our, basically under the covers, there's our .NET runtime code is essentially saying, oh, look, they've registered this serializer. Use this serializer to go and convert the JSON that Lambda's giving us into the POCO that the method takes. So after that, again, we're getting back into the same pattern we've seen already today, where it's, we're looping through the records of the event, but we're going to use our service clients to call our detect labels, passing in requests, getting back a response. And then essentially we're going to go tag our object. So like I said, once you see the pattern of SDK, it's basically, okay, now I just need to go look at the docs to see what that operation does and what fields to set. From the SDK's point of view, the pattern is always basically the same. So that's really all it is. And so, I can pull in whatever class libraries or whatever I want, to do this. So there's not a lot of structure on the programming model for this. So
quick question. Sorry. In terms of threading or tasks or anything, so if you happen to need to do two things at once, are you going to be just restricted to one virtual core in like a deadlock, or how does that deal with things like
if we go back to here, so remember, each one of these blocks is only processing one event at a time.
Correct. So in your code block, if you were to say, new task or task got run to spin up a different task, is that something that could deadlock, or is that something that you can access multiple threads or a thread pool? How does, I guess, under the covers, what is it doing in terms of threading?
It's not doing anything special. So it's using the same regular .NET task scheduler. The caveat I would give you with that, if you're saying I want to new off tasks, like if you new off tasks that you don't essentially await for by the time this is done, because once this method returns, or essentially this task here is complete, Lambda is essentially going to then freeze that compute environment. So if you have created threads or tasks that you just want to run in the background, those tasks are frozen now once this method is returned. So make sure everything that you want completed is completed by the time you return out of this method. This is my advice. Is that?
Yeah, so I understand. Like, so you go into the method, it basically thaws the environment. You come out of the method, it freezes the environment, so to speak, or compute section or whatever. But so if you were to actually scale up your service and say you had, 32 gig or 64 gig, whatever changes the CPU size, is that just scaling it's not necessarily scaling the speed, it's more of the quorum you get of the CPU? Like, I guess you're not going to basically have multiple cores running it. I'm just trying to figure out what that kind of translates or roughly looks like behind the
essentially
scenes.
means like this box here, what percentage of a core or number of cores that actually gets to work on there. So that process gets that amount of cores. So
Okay.
So if that makes sense?
Yeah, I think so. Thank you so much. Thank you.
Yeah. Okay. So let's do a deployment here. How are we doing on time? All right, let's see if we can do a deployment here. We'll say we're going to name it Lambda 1. We're doing .NET Core 3.1. And what we're doing here is we're defining a function handler string. So this is this string that essentially gets created. That is what identifies to the Lambda service what piece of code to run in there. So you can imagine essentially there's a bit of a reflection to say, go find this assembly, this type, and this method, and that's what we know to invoke whenever there's an event coming through. It's not actually reflection we're doing, but it's on that sort of mind thought. So next, like we saw in Beanstalk, we want to give ourselves some roles. We need a role that's going to grant us access to S3, and it's going to give us access to detecting our image labels on there. And this is where we can also say how much memory we want to go. And again, remember, memory is really, this is really your vertical scale of it. So if you want this to run faster, if you want to really reduce the cold start, make this number bigger. So it's not really just a question of how much memory you think you need. You can also control the timeout here. This is sort of to just sort of make sure that there's no like runaway, something's running in an infinite loop and forever, getting that charge on there. I could set environment variables. I'm going to just keep this short though and just push upload. And so basically we're doing a build and populating that to S3, and that's it. That is the function is deployed and it's ready to be used right now. So this is our view that we have inside the toolkit for these things. It has features where you can basically do a remote invocation. We've got a lot of what those sample requests look like. Like I mentioned, really what's being sent to Lambda is always a JSON document. And here we're seeing a document saying this object key in this bucket. I can run this here. This will fail because this object doesn't actually exist. But you can kind of see how I could craft some, the JSON document I want and go ahead and actually invoke it here. But let's actually do it for real. So I'm going to go create another bucket here. Or actually, we'll use the bucket that we created, the normj Dallas. So I'm going to use that. And I basically need to hook that up to my Lambda function. I'm going to say add. And I'm going to say normj Dallas. And the prefix and suffix means basically I can say I only want this event to fire if that object key, which you remember is not a folder, it's just like this is the part of the string, the part of the object keys prefix that I actually want to fire the event on. So if I only want this to fire on things that are that start with an image key or something like that, I could do that. But I'm just going to fire it for everything. So I'm going to connect that up. And now it's connected. So let's see it all in action. I think I have a picture over here. So this is a picture of where I went backpacking a few months ago, getting away from all of the COVID funness. So let's see what that gives us. So I'm going to upload up to S3. Toolkit is basically doing the same thing that we always do, that we just saw before, using the SDK. And then if we go look in our logs, for our Lambda function, we can see here's the invocation that failed because I sent the dummy one in there. And we can also see that it actually worked to find out the tags. And if I go back to the S3 browser, we can see we got, tags, everything in there. It can tell that I was actually in nature and there was water and rubble, that the kids had a lot of fun playing in all those things. So hopefully you can kind of see, like, with that Lambda function, it's kind of a common thing that people do is they basically use Lambda to sort of tie a lot of AWS services together. It kind of helps build their microservice applications. Like, it's very common to set up REST APIs for with Lambda, but it also is very common to just say, I want to, obviously S3 has a certain functionality, DynaDB does a certain things, but I need to customize them. I need to do some mutations. And I can use Lambda functions to sort of glue all these services together and build stuff in there without having to maintain a lot of extra things for that.
Norm, real quick question.
Yeah.
So you're showing deploying this out to AWS. If you were to run the normal the SDK that has the local invocations, what's like the best way to do those AWS invocations? Basically connect to the live AWS services, or to basically mock those out or something when you're running the local Lambda test invocation?
So I want to make sure I understand. So there is 2 local ways for .NET for people can do. One is a tool out there called SAM, Serverless Application Model, which has its own CLI. It has a way of basically running things locally in a Docker container, and they have some debugging capabilities there. We also have in the .NET space,
I was thinking in the SDK there was also like a local way to execute the Lambda.
The SDK is always going to go in, like what we're doing right here in the toolkit. It's going to go and invoke the live function. So that's
because this. Okay, is it the live function? I was thinking when I was developing something last year, it was something you could actually run in your own browser without connecting to Amazon, and actually test it that way.
Is it this that you're talking about? Is going to launch in a second?
Possibly. Let's see.
This one?
I think that is. It's literally been a while since I've looked at this. I think this is what it is, the mock one. Yeah.
Right. Yeah. So this is the other way you can do local testing on it. So this is the tool that we have that the toolkit will set up, and essentially works the same sort of way. I can go put in a object in here, and now I can go in and set a breakpoint in my code. And it should, if I go execute it, I'll go step there and I can start stepping through it in there. So the way this tool works is it basically, it is really what it is. It's just actually an asymmetric core application that loads the Lambda project in its processor space. And then you're basically, in Visual Studio, is basically debugging that tool. So that's how it works. So it's a pretty good tool for very quickly getting set up and debugging. You don't need the extra things like Docker or other tools. It'll actually get set up when you set up Visual Studio. But it is a tool that's just really good for testing your application logic. It's in no way trying to say this is like a Lambda environment where you're running on Linux and things like that. And in this case, it's whether it's it's gonna be using the real recognition service, the real S3 service. I could probably work around that if I wanted to have it detect whether I was running in debug mode, and then use mocks for these clients. If I want, like I could change my constructor because it's using that same constructor, use that constructor to figure out whether I'm running in Lambda or not, and use different versions of these interfaces for that. If I was trying to mock those out, if that's where you were going, I'm not
correct. Yeah, I was trying to figure out, like, is the local testing pattern recommended to always connect to Amazon, or to fake the constructor, or you change the injection or something like that to basically test with local mocks or fakes or something?
Yeah, I mean, my recommendation would be always, the test tool and SAM, that is a useful tool when you just want to do a quick ad hoc debugging, something's going wrong. But from testing's point of view, I would recommend basically always using your integration tests, making sure that your constructors are taking in the interfaces and creating the mock versions of these things, like use mmock or something like that, and do that. And that's what I've done many times. And I actually should update this blueprint to show examples of that. But that's generally what I would recommend, is just mock out those interfaces with using mock or something like that.
Cool. Thank you so much.
Yeah. Okay.
All right, so Norm, we have another question.
Okay.
It's a little bit related to the startup again. Do you see any advantages of having multiple functions inside of an AWS Lambda? In other words, is it possible that multiple functions inside of a Lambda might have that assembly get loaded in the same compute environment, so state could potentially be shared, so startup time for the Lambda could be lessened for the second function that could be called, or subsequent function that could be called?
I would say depending on your code model, your usage pattern, you could have less frequencies of cold starts if everyone is hitting, if it's helping you get that consistent load across Lambda. And that is definitely true. The thing to be careful though is also to make sure that you're not like putting too much into that project that's causing excessive things to be happening during integration or initialization time, which could affect cold starts. But yeah, it's a common thing we do as well. I know we're out of time, so I'm just gonna show this. And I think I mentioned before, we also have like the ability to run asymmetric core applications as Lambda functions. And then what that really means is there's one Lambda function that's running the asymmetric core application, and it's essentially dispatching the request based off of asymmetric cores routing. So that sort of fits that same example of like, it's one Lambda function, but it actually is deploying, sending it to the right route based on that. If that made sense, roughly, hopefully. So yeah, I'm sorry, I'm running long. I can keep going, but I don't want to keep everyone too long or whatever. So
if you're okay with going for a little longer, okay, well, we have someone says keep going with an exclamation point. So sure, if you have time, I think there are plenty of folks here that would love to see more if you have the time for it.
I wanted to. So the main thing is I really still wanted to make sure we covered the Lambda case. The asymmetric core wasn't exactly the main use case I wanted to show, but it'll work. So what we did deployment that we deployed straight to Lambda in that case, where we deployed to Lambda and then we set up the event source directly in there, and that's totally fine to do. The other way you would do this approach, and that's that project template we have that was called serverless. So the difference between the Lambda blueprints and the serverless one. The Lambda ones go straight to the service. The serverless ones, what they do is they actually go and deploy via CloudFormation. And CloudFormation is a way of saying, I want to go and deploy all of my Lambda functions together, all at one point, all together. So actually, what I really wanted to do. So here is a serverless demo for WebSockets. So, and this is a case where I need to actually deploy multiple Lambda functions all together. So if we look here, and I'm going to take the super fast version here. But high level is it's kind of API gateway supports also WebSockets. And in there, you basically need to have like a connect Lambda function, a actually do your work type method, and a disconnect method. So here's the case to deploy this application. I need to deploy multiple Lambda functions all together. And so you probably don't want to do like 3 different right-click deploys or 2 different, whatever you're doing for deployment. I'm doubting most of you aren't doing deployment straight from Visual Studio, but as you're doing your development, you might be doing that. So with CloudFormation, we can actually write what's called a CloudFormation template, which defines all of the AWS resources. So for this blueprint, we're creating, here's a done table that we want to create that's storing connection information for my WebSockets. Here's my Lambda function here. And I can actually pass in, environment variables, here's my table that I created, pass into there. Here's that function handler string. So everything that we just sort of did in that wizard, and we can do in here, but we can also deploy all of our resources as one unit. So when I deploy this, the wizard changes slightly. Now we're not deploying to Lambda, we're actually deploying to CloudFormation. So if you're going to get too far in AWS, you're probably going to really need to know CloudFormation because it's going to be one of those key services you're going to use for deploying and managing multiple resources. There are a lot of tools on top of CloudFormation to make it fit whatever is your pattern. But here I can specify the table. So I mentioned there are multiple ways while this is going. CloudFormation, you can write your templates in either JSON or YAML. We also have a new project out there, it was sort of GA'd this year, or a reInvent last year, called the CDK, where you can actually use code to essentially define your CloudFormation templates. And basically, when you run it, it generates the template for you. And then you send the CloudFormation, and it will go in. This is the CloudFormation view in the toolkit, which will basically say these are all the events coming in of how all of these resources get created. The toolkit has, and I'm a bit biased because I wrote this feature, has some IntelliSense too, or this is where you can say, I need to go add more Lambda functions or aliases. It does have some IntelliSense helping features out there for you. So that's in there. This is a feature of the toolkit to see basically how I want to help craft those things in there. We could do a whole nother talk on like how you could write CloudFormation scripts in the .NET CDK and do all those things there. So there's our application. It's all deployed. And so here it created all of our resources in there. So this template's kind of cool. I don't want to go too much into it, but basically you can use WebSockets now and have it broadcast all of your messages on there. My main goal though with this demo was just I really want you to know, like, either you can deploy to Lambda directly and then manage all your event sourcings and all those things afterwards, or you can do deployments via CloudFormation and basically write a template that defines everything you want to deploy at once. Here's multiple Lambda functions. It's here. This project is a bit simplified in that all of the Lambda functions are actually in this same project. And so it knows just to go build this project in there. You might not want to do that. You might want to have all your Lambda functions in separate packages. So what I would recommend in that case is, maybe move your serverless template as like a solution item. Maybe put it above there. And in that code URI, for each of your serverless functions, you can actually say, oh, and this is in project 1. And the disconnect is in project 2, something like that, right? Whatever is your actual .NET projects. What our tooling knows is basically when it's taking this CloudFormation template, it'll know, okay, go find the code based off of the relative URL of this property from this file and it will build those projects up and deploy them. So it'll actually, allow you to build and deploy multiple projects together as one unit via the CloudFormation template. So yeah, that's what I wanted to briefly show there. I'm sure it's a bit abbreviated there, but I want to keep going. Any questions anyone wants to ask on that, or?
Yeah, we had a question about how would you roll back a Lambda function to a previous version?
So for that is Lambda has a whole set of features for basically, I'm going to flail here a little bit. I don't have a great way to demo that very quickly, but essentially you can create, I think that's in here, right? You can create aliases. So I want to say this is the dev alias. And so essentially you can say, this is the dev alias. So, sorry, let me stop writing. Let me just talk in general. So the pattern you would use is, and this is what you should do when you're getting beyond just the, I'm doing the quick and dirty testing, is you want to say, I want to create an alias for my Lambda function saying, this is my dev Lambda function, and this is my prod Lambda function. When you create a Lambda function, you can also tell it to actually publish it as an actual version number. I think that's in here, auto publish to, publish it or something. Yeah. Anyway, you can tell it to say, I want to publish certain version numbers. And then you can basically say, for my alias, I wanted to point to this version number. And that could be, so I want to publish to the latest one. You find a bug in that when you've got an outage or something because you've deployed something bad, you can say, I want to update my alias back to the previous version number of the Lambda function. So, and that's how you'd roll it back. That is my quick and dirty 10,000 foot view. But basically, it's a combination of using Lambda aliases and function versionings.
Can the serverless.template file be split in smaller files? Is there a way to, to overlay it like you overlay application JSON files and so on and so forth?
There is not. I wish there was. There are other features that you can have with CloudFormation that aren't directly exposed in the toolkit, where you can have like nested stacks, so you can create a stack with it. So a CloudFormation deployed template is called a stack, and you can have the concept of a nested stack. I'm not going to claim to be an expert at it because admittedly I do a lot of demos and not the very fancy ones. But that's the main way I've seen customers do that type of thing when it comes to writing CloudFormation templates. I would recommend, and this is actually a pretty good resource for anyone also who wants to get know more about AWS. There is a thing out here called CDK Workshop. So this is basically where you're writing code to generate that. Let's see if I have an example. I'm sure there's I'm just sorry, I'm trying to find a fuller example here. You're actually writing .NET code or TypeScript or Python that actually use to correct all of your resources, and you use the CDK to actually deploy your CloudFormation template along with it basically runs your code to generate that CloudFormation template. And then you can use all of the usual tricks that we all know how to do for code reuse, writing functions and using libraries and things like that. So let me put this in the chat window. So it's a pretty good workshop going through the .NET 1 to kind of get started on how do you create infrastructure as code, which is a big movement going along through a lot of people's areas. I will say the Lambda part of this workshop is just cheating and just doing Node.js for the actual Lambda function, but all the actual infrastructure code is being done in .NET. So. All right. Any other questions or anything?
Darren did have a question. Can you use gRPC with WebSockets?
Not through Lambda. The way Lambda works, that doesn't work because Lambda. I mean, it's WebSockets for basically broadcasting messages out to all the other connection endpoints. And there is a live, WebSocket connection maintained between your client application and the API gateway, which is like the front end part. The actual Lambda compute environment is still an event-based notification, right? So whenever something gets sent through the WebSocket, it's going to go trigger that as an event to one of those Lambda compute environments, right, and send that back. So that's still sort of a stateless sort of compute environment. So in that case, it's not. If you're doing gRPC, that's the case more where you probably want to go use a container-based approach or a Beanstalk approach.
Thank you.
Yeah. I think all I have left in my slides are basically, hey, we covered a bunch of stuff. Hopefully it all made sense. Here's some useful links that we got. This is like the .NET page on our main AWS website. This is where we have our blogs. I write some of our blogs that go there. And again, if you're coding, I would also really recommend making sure you check what we have available on the GitHub one. And like I said, most all of the stuff that I work on is all open source. So track things through there. Do things. So. Okay.
Well, Norm, thank you so much for this. This is great. I think I love the interactivity with the folks in the group, and every time we've done something with AWS here, Eric and I have done a couple of different presentations, but not to this level. It was mostly things like, hey, here's how you can take a really simple .NET Core app and put it on EC2. Here's how you set up a load balancer. Here's how you do this, or here's how you do these basic things inside of AWS, and here's how it translates to what you did in the environment. But now seeing what you just showed here is a fantastic next step for everyone.
Cool.
In the environment here. If anyone else has any questions or anything else, let us know. Else we can let Norm get back to having dinner, probably.
Yeah. And yeah, also, as David knows, I do try to connect with people on AWS on Twitter. If that's where you want to go, you can always reach out to me there. I do my best as I can there. So.
Well, thank you, Norm.
Yeah. Thanks for having me.
All right, great. Well, this concludes the October meeting. Thank you, everyone, for joining. Russell has the YouTube video up, and I'm not sure if he has to do any kind of post-processing. I think it's pretty much done, so he'll be able to finish it off. Again, thanks a lot. We'll see everyone next month.
One final announcement.
Oh, sorry. Go ahead, Eric.
Happy birthday, Russell.
Happy birthday, Russell.
There we go. All right. All right. All right. Thanks a lot.
Good night, everybody.
All right.